Hi, welcome. It's your teacher, Michael Lane. Now, this video is made for those who are going on the marine biology trip, which is in just a few weeks. We're doing something different. You should have by now have gotten a package that has, for one, your textbook in it. And this is the textbook you'll be receiving. There's reading assignments also that'll be in this packet with you. You get a handbook. The handbook, and I do encourage you to read the handbook before the trip. Let your parents read the handbook before the trip because there's so much information in the handbook. Even the daily itinerary, tons of info. Everything basically you're going to ask about the trip, it's already on there. And so go over that. So you'll have that handbook and bring both these with you when you come to the Keys. So parents, if you need to copy something out, please copy it out because they need to bring the handbook on the trip. And you're going to have this book also. But today we're doing something different. This is going to be your first lecture. Now normally, as I said, we're doing this a little bit different. Normally when we go down to the Florida Keys and everybody flies down, that first night after we have dinner, we've had orientation, we do all the stuff. Then after that, we go into the first lesson that evening. But it's always been hard because some people, for their flights, people who had to fly, for instance, from like Alaska or California, have been up. They would have been up from like about 3 a.m. And it's just a killer trying to do that and then sit in the evening, in the dark. We put lights up and everything around our marker board right down by the ocean. And trying to go through a lecture is just exhausting. So we've had students ask this. We've had teachers also advise this. So this year we're doing it a little different. We're going to take the first lecture, which is what this is. This is the Introduction to the Marine Environment. And we've given you worksheets you should have in your packet that you got with your book and your handbook. We're going to go through those, and what you're going to need to do, now this is where it's going to get a little weird, because I can't give you the lab book yet. Because the lab book, when you take the evaluation, I hate to say the word exam or test, when you take the evaluation at the end, the evaluation part of it is open lab book. So I can't give you the lab book right now because there's so many people. There's well over probably a couple of thousand people who have been on this trip. They get to keep their lab books, and there's lab books floating all over out there. I don't want you to have the lab book from someone else. And so we don't get the lab book until we get down there. But we needed to give you the sheets that you need to have for this first lecture. So it's just a little weird way of doing it. We're giving you the sheets. You copy the stuff down as we're going to go through this lesson today. Then when you get down there, when we get to the Keys, we will hand you your lab book. And believe it or not, it's thicker than this thing is, than your textbook. And you'll be filling it out. You'll need to transcribe or you might have to staple these things in there, these pages. My suggestion would be to transcribe it when you get down there. But we can talk about that when we get in the Keys. The whole point I'm trying to get across here, I'm going the long way around the barn. What I'm trying to say is we're doing the first lecture instead of in the Keys like we've always done for almost 40 years. This year, we're going to have it on this YouTube thing that you can watch it. And you can pause it at times if you need to look at the answers and stuff as we go through it. But I'm going to try and make this as painless as possible as we go through it. Because I know, just listening to a guy stand and lecture, those of you who have seen me teach, you know that's not my style. And I feel really confined because normally on this lecture, I'm in the group with the students. We have activities and stuff. We're still going to do those activities, but you're going to do those while we're down there. This is just the note stuff that we can give you. So you'll notice in your packet, it starts on page 7. And then it goes through, it skips a few, and it has a whole section that's in numerical sequence, but then it skips some more, and then finally it ends at page 23. I know, it's just weird, because those are the pages specifically I'm covering in this lecture. So that's what this is all about. To get those sheets of information so we don't have to do it down there and waste some of your time down there with this lecture. We can do it here. So I even hate to say the word lecture, but that's what we are. We're going to be giving you notes. So those of you who have seen me teach before, you know this is not my normal style of teaching, just standing and going through. Even when I taught in the classroom, this was not my normal way of teaching. But We're here in the studio here in Kewaskum, and we're trying to get this as far as fun as we can through the whole thing. And just to start out, to let you know, our trip, when you get the handbook, you're going to see one of the sponsors of our trip is Mucho Mango. You ready for a commercial? Hi, this is Mucho Mango from Arizona Tea. Arizona Tea donates Mucho Mango for our students to drink on the trip. Mucho Mango is a delicious drink. Yum, 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 yum. You can buy it in stores up here, and I encourage you, try out Mucho Mango from Arizona Tea, and you will enjoy it. It's a great drink, and it's the official drink of the marine biology trip. That was the end of the commercial. Now let's go back to work. You ready? Here we go. Let's begin with this introduction as we get going. Now, there's a couple of things you got to understand about the marine environment. And if you have your page that's open there on page 7 of the handouts that I gave you, you're going to see at the top of this, it gives you some terms. Now, some of you, this is just how it is in these classes every year. Some people have had many classes in biology. They've had ecology courses. We've even had some students in the past that had botany and zoology coming down. Others have never taken a class on biological sciences. That's okay, because we teach you everything you need to know on this. And the first thing we got to come across is something that we're going to be talking about a lot the whole time we're in the Keys, and that is abiotic factors. Now, the word abiotic, as you can see on your sheet here, and we have the PowerPoints put together from your sheets so you can follow along. The definition for abiotic factors is non-living factors, non-living things, if you will, that have an influence on living things that we're going to be studying. As you come down, we're going to be going out to the ocean every day, and you're going to see and collect a lot of living things. But for these things that God created and put here, God has designed them to be able to live in these environments where non-living things are affecting them. So that's what this is going to be about. So just hold on to that. If you're still a little puzzled, it's like a non-living thing, like temperature, for instance. Temperature determines a lot of where creatures live. I mean, when was the last time where you were walking down the street and went into McDonald's and had to stand in line behind a polar bear? You don't see a whole lot of polar bears around here, nor do you see giraffes and things. But polar bears, they like colder weather than what we have around here. So it's a non-living thing. The temperature is a non-living thing that has an impact on a living thing. It's stuff like this. If you're a plant, hey, sunlight's pretty important. So we got to have sunlight. Sunlight is a non-living thing. So these are called abiotic factors. A is like the alpha. Putting an A in front of something in Greek negates it or means like non or no. Bio, if you break this word down, bio is the Greek word for living thing. And so non-living things that are factors for living things. So now that we got that, this is going to be the first part of this lecture and this lesson that we're doing. It's just talking about these. And to begin with, some of this is just old hat. I know most of you, probably all of you, maybe except one, knows this already. But let's talk about the oceans of the world. Now, the oceans cover about 71% of the Earth. Our planet looks very blue from outer space, if you've seen pictures like that. But we're not looking at all of the oceans. We're not traveling everywhere on this trip, so we're going to be going to certain places. We are in what a lot of people call the waters around the Keys in the Bahamas, the Caribbean. Actually, it's not. The Caribbean is south of Jamaica, Cuba. Well, Jamaica sits in it, but south of Cuba and stuff, and along the islands going down all the way to South America. That's the Caribbean Sea in there. People call it the Caribbean all the time, but actually it's the Atlantic. We're going to be dealing a lot with the Eastern Atlantic, the subtropical Eastern Atlantic, and we're also going to be dealing with the Gulf of America. These are our two places. Matter of fact, our island, when we get down there, we're going to be on a body of water. As you look out, you're going to see the body of water. That is the Gulf of America. On the other side of our island is the Atlantic Ocean. These are the areas that we're going to be studying. So that's the first thing. So if you look at we have a picture here of a world map, and if you're looking at the world map, you can find the United States there. We're on the eastern side of the United States there. You can see where Florida the peninsula part of Florida coming out, and we're down in the Keys is where we're going to be working. And you can see I have maps also in your textbook that you can take a look at and see specifically on this. And we'll show you some other slides as we keep going. But this is the ocean area of what our planet is made of. You can see there's a lot of blue here, a lot of blue. So we are a water planet. So the next thing to talk about is the water itself, seawater. One thing, if anybody has ever done saltwater aquariums and set them up in your homes and stuff, if you're a saltwater aquarium enthusiast, you know you have to deal a lot with salinity. Salinity is just, the definition of this is the total salt concentration. And it's measured in parts per thousand. You can see the abbreviations there in your notes, 4 parts per thousand, and this is how they measure it. And it varies. A lot of people from the Midwest think that the ocean is the same saltiness all over. It is not. As a matter of fact, even from one side of our island, like the Gulf side to the Atlantic side, the salinity can be much different. But it's very close to being about the same. Approximately average seawater, if you just went out into the middle of the Atlantic, took a glass of seawater, that would be like taking 1 teaspoon of table salt and putting it into 1 glass, a glass 8 ounces of water, stirring it up. You roughly have the salinity of the oceans. It's about like that. And the way we talk about this, it's 35 parts per thousand. Which, if you want to put this in a different way of thinking, that would be about 35 pounds of salt for every 1,000 pounds of water. That's how this is measured. And it is lower, as I say, it's not always the same. And it can change even during a day in certain areas. There can be slight changes of it. And it is lower, you have lower salt concentrations where there are rivers nearby, freshwater rivers, adding fresh water into the salt ocean there. Or after heavy rains, hurricanes in particular, really wreak havoc on a lot of the oceans and stuff. Also, as the ocean gets colder, if you move further to the poles, the salinity changes. It goes lower, where now it's just the opposite for making it higher. In the tropics, we're in the semi-tropics down here, though it feels like the tropics sometimes. The semi-tropics down here, it is higher because the sun is shining, and that is our #1 nemesis, sun, because there's a lot of solar radiation down here, and the sun can cause the ocean to evaporate, which it does. And because the water itself is evaporating out of the ocean, what's left behind is the salt. So as the water gets warmer, it gets much saltier. And I remember even when I used to live in the Bahamas, going into tide pools after big storms with waves got crashed up into tide pools way below where the ocean normally is. And after the sun has been sitting and baking, it hasn't rained now for a while, the water level starts to evaporate down and it gets very concentrated. And if you go in there, wow, it's really salty. If you taste that water compared to the ocean, whoa, it's so much saltier because evaporation, that is a major player in this. So what kind of salts are there? I mean, what's in there? What type of salt? It's just not table salt. Table salt is that you have, like when you go to McDonald's, put it on your fries. That's sodium chloride. Well, there is sodium and there is chlorine in the ocean water, but there's more. Our ocean water that we have, basically, remember, this is just an average sample of ocean water. It's about 55% chlorine. The next most popular element that you're going to find there is sodium. About 30.6% of a glass of water, of the salts in the glass of water or in a beaker full, is going to be sodium. The next most numerous, or it's not the next most numerous, but as we keep going through, there's a lot of magnesium. Magnesium is 3.7%. Sulfate, and in certain areas it gets pretty high, but the average of sulfate is about 7.7%. We'll be having a lecture when we get to things called mollusks, seashells and stuff like this, where we talk, and corals also, because calcium is very important to them. So there is a lot of calcium compared to fresh water. It's 1.2%. Doesn't sound like a lot, but it is a lot compared to freshwater bodies. And we'll talk about how that impacts. That abiotic factor is a major one for certain animals, as we will see. Potassium is another one that there's a lot of potassium. It's only 1.1%, but it's there. And then we can't go through the whole list because almost all of the natural periodic table of elements, I mean, there's even gold and silver in ocean water. It's a very small, minute amount. It costs more to extract it than you would get out of it value-wise, but we just call it minor elements, and it makes up the 0.7% that's left over. So that makes up. Now, when we get down there, to help illustrate this, I would normally do this right here with you, and I would have students come up and do this experiment. There's a lab page that will be in your lab book that will be talking about doing activities with salinity in an aquarium. And we're going to have aquariums down there. Each of you will be placed in, as you can see in the handbook, you're put into different groups. And each group has a huge aquarium that you will collect your specimens and put them in. Plus, if we need, we can set up a swimming pool and pump seawater into that, and we can set up organisms that way. And there's other aquariums that we will have at times. But there are certain activities that you will do as your group with your teacher and dealing with salinity levels in aquariums. So there's other experiments too that you'll be doing. Some of them are microscopic work. We bring down microscopes and you're going to get to work with those also. But that's seawater. That's going to be one of our abiotic factors. Another major abiotic factor are tides. Tides, the tide coming in, the tide going out. There's some beautiful songs written about that. Some love songs, ooh, how sweet. Anyway, as we talk about tides, there are ways that tides are actually, they're timed. You could set your watch by tides, but how they are formed and stuff and what they do to living things is really important, because as the tide comes in, some animals are stuck in a spot. They're stuck on like a rock or something, and when the tide is high, they're underwater, but then the tide goes out, now they're exposed to the air. God has designed certain animals to be able to live like that. Not all creatures can. Fish generally don't stay up above the high tide mark when the water goes out for so many hours and they're just left out in the sunlight. It'll kill them. Other creatures you're going to see are designed for that specifically. And it's really cool how they do this. But what causes tides? Now, I've got some illustrations both in your textbook and in your lab book here. Certain things that cause tides, it has to do with the gravitational pull of the sun is one thing. The sun does have a gravitational pull, but the most important one is the moon. Yes, that big white thing floating around in the night sky. And as the moon, where the moon goes around the earth, it actually has a strong gravitational pull, and it actually pulls the water towards it. So as the moon moves around the earth, it can actually pull the water towards it. Thus, we have a high tide. And as the moon keeps traveling around the earth in 24 hours and 50 minutes, as it goes around, that big bulge that it's pulling moves with the moon. Now, as Isaac Newton, the great Bible scholar and scientist, noted, for every action, there's an opposite and equal reaction. If there's a bulge on one side of the planet, like you see in this illustration here on your handout, if there's a bulge on one side, there's also a bulge on the other. And so those things actually cause the tides. The moon is the most important thing. Matter of fact, in your handbook, you will probably notice we have a tide chart. Some of our excursions have to be timed with the tides for us to see the certain animals and plants and things. So we have to know when the tides are. And the way it's all set up, it's set up by, God designed it because of the moon and its gravitational pull. One other thing that a lot of people don't think about with tides that causes tides and can impact tides are weather patterns, low pressure systems, hurricanes. Hurricanes can actually cause big, massive tides. You've all watched on the news where there's a hurricane going to hit Florida or something, and they talk about the tide surge. When the tide comes in with a hurricane, it's much higher. And if it happens at the time of day when it's a high tide, it's even higher yet. So that is what is dangerous in hurricanes. The wind is dangerous, yes, but it's the tides. They can come in. And these islands down where we're going in the Florida Keys, for instance, on the last hurricane that they had, most of the islands here were totally submerged. I mean, all underwater, water all the way across at the tide, high tide, because they hit at a high tide, and the tide was already high. Hurricane made it even larger. And so after the tide went out, there's dead creatures everywhere from the sea that get trapped on land. As a matter of fact, there was a video I remember watching on the news during one of these down in Key Largo on the last hurricane when it came through at high tide. Sharks were swimming down the street People actually got out and filmed these with their cameras of sharks, good-sized sharks, swimming down the streets, bull sharks and lemon sharks. It's really cool to see stuff like that. But that's what happens. And it all happens because the surface of the earth gets pulled by the sun, but mostly by the moon. And because the oceans are not rocks, it's flexible, it moves, they get moved very easily. But like I say, the largest impact is going to come from the moon. Now, a tide, if you really want to be technical, is actually just a big wave. The big wave just stays wherever the moon is. As the moon moves around, the bulge of this wave just keeps going around with it, and it slowly goes around the earth. The closest gravitational source to the earth is, of course, the moon, and it's got this gravity, and it can actually do this. The moon rotates, pulls the tides with it. And because of centrifugal forces, a tide is found, as I said, on both sides. Don't forget that. So there's tides on both sides during just following the moon. And what's really interesting, if you're out in the middle of the ocean and it's just water everywhere, you don't know if you're high tide or low tide. You can't tell out in the middle of the ocean. The only way you can tell the tides, you got to be close to shore, where you can actually see it go out and come back in. So you notice it along the shorelines. And the area of water between these bulges of when it follows the moon, where it's not bulging, those are low tides. That's how this works. And a tide, which you will notice down there, students notice this within the first couple of days, how the tide comes in, the tide goes out. The tide comes in, the tide goes out. And it happens each day 2 times each because tides, because of the rotation of the moon and having this on both sides, tides occur approximately 50 minutes later each day. So that's why it varies when you look at the tide chart in your handbook. If you'll notice, it will be about 50 minutes roughly each day because it takes the moon 24 hours and 50 minutes to go around the planet one time. That's why it's like that. And there's 2 types of tides that we're going to be seeing and experiencing down there. Ones that are called spring tides. This is mostly when you get a full moon, and you can see the illustrations that we have in your lab book and also in your textbook. You get these spring tides. This is when the sun and the moon align. Whoa, you get very, very high tides. You see, the tide is not always the same height. It depends on the phase of the moon, and it depends on the position of the moon and stuff, where it's at, and its rotation around the earth. So it can be a really high tide, or if the moon is in a certain position, it can be a very, very low tide, which we call a neap tide. These are illustrated in your book, and we have here a 24-hour tide table that you can see in the PowerPoint that's being shown right now, and seeing how it varies and how in a 24-hour, roughly how the tide is moving. It follows the moon. Okay, that's it with tides. Let's move to the next section. I already mentioned this one, solar penetration. Solar penetration is a very, very impactful abiotic factor. As a matter of fact, I get asked by people, and I've been asked already for this year, what's the most dangerous thing I'm going to experience? This is usually parents asking this. What's the most dangerous experience my child is going to have down there? Is it the sharks or the jellyfish? And I usually say, neither. It's the sun. People in the Midwest, I love when people in the Midwest come to me and they say, I never get burnt. I never get sunburned. Listen, in that climate, you will. We strongly encourage you to wear sunscreen, not the tanning oils. They just really focus the burning rays on you good. But to use something at least a 15 SPF or stronger, because you will burn down there. You're in the sun a lot, and there's no shade when you're out snorkeling, and the clear water of the areas down there act almost like a magnifying glass and intensify the burn on your body. So it's the #1 nemesis we face. So make sure that you're prepared for that. But solar penetration is also a very, very necessary and very important part or abiotic factor for living things. You see, sunlight can penetrate down through the water. Now, if you live in the Midwest, most of the places that you live, or in other places in the United States, you go to a lake or whatever, it's not the clearest water in the world. You could come down the Keys. We have been down here. We had over 100-foot visibility. And if you've seen some of the pictures, even matter of fact, some of the pictures in our textbook, and like even the back cover of our lab book, or of our textbook here. This is one of our former students diving, and look how clear the water is. We didn't do anything to this picture. That's how clear the water can be down there. It's not always like that, but it can be. And when you have super clear water, the sun's light can penetrate deeply. Now, this gets really interesting too, because there are certain factors that can limit how far the sunlight can come down. Sunlight travels in waves, in wavelengths, and we're talking about the visible light here. And depending upon how clear the water is, it can go pretty deep. Otherwise, the water itself can filter out the sunlight. And that is important. Plus, there's also plankton in the water. There's sediment and stuff, particularly if you live in the Midwest. The water can be very cloudy. Solar penetration is pretty low. I have scuba dived in some of the lakes in Illinois and in Wisconsin. Not the Great Lakes on what I'm talking about here, but in some of the other just normal lakes that you find inland. And I have hit total darkness at like 18 feet in some of these. Where in the Keys and in the Bahamas in particular, you can see the bottom perfectly even at 100 feet. It's so clear. But even so, even if the water is that clear, sunlight gets filtered out because the wavelengths are not that powerful. So as we look at this, this is important abiotic factor for living things like plants. Plants in particular, they need sunlight. If the water is muddy, the solar, what we call solar penetration, that's the penetration, how deep the wavelengths of the sun can penetrate into the water, it gets limited if you have really murky water. Like I say, diving in some of the areas around here, I mean, it's really boring. I mean, it's really boring compared to what you come out to a reef down here in the Keys or in the Bahamas and you see stuff, well, much different. I'm not a big fan of scuba diving here in the States. I mean, to be honest, it's pretty boring. Yeah, you see fish, you see rocks, and most of your algae are slimy things and like, ugh. Not in the Keys, not in the Bahamas. You get lots of colors everywhere. It's so beautiful. But the problem is, as you go down, certain wavelengths of light get filtered out and they disappear. You can dive, and some of you probably will. None of you on this year's trip are scuba divers. You're all going to be snorkeling. But even as you snorkel, those of you who are good at snorkeling maybe can dive down on a breath of air down to 30 feet or something. You get down there, you're going to notice the colors start to disappear. Red is the first one that disappears. Now, if plants need red sunlight, they have to be very close to the surface. Because if you're trying to live 100 feet down, red wavelengths of sun get filtered out before they get that far. If you need blue, blue penetrates pretty deep. And so, hey, you can be found almost anywhere that way. So plants and animals are going to die if they don't get enough sunlight. But just as Jesus Christ is God's son and he calls himself the light of the world and he gives light, the sun that we have in our solar system provides life for this planet also. It's a really interesting thing here that we have these two things together. I mean, Jesus even said in John 8:12, this is out of the God's Word translation, I am the light of the world. Whoever follows me will have life filled with light and will never live in the dark. Light is really important for things, for life, both eternal light through Jesus Christ, but also dealing with just living things in biology. And as I said, sunlight contains all the different colors of the rainbow. As a matter of fact, a rainbow is pretty much like a prism, and it separates the wavelengths of light. Maybe you've all heard of Roy G. Biv. Red, orange, yellow, blue, or green, blue, indigo, and violet. Roy G. Biv, the spectrum of light. I asked one time on a class when I was teaching middle school many years back, I asked the class to define Roy G. Biv, and I had a student who wrote down as an answer, the inventor of the pinhole camera. I don't know where she got that, because it's the light spectrum is what we see. When you see a rainbow, you see Roy G. Biv in that order. Some people don't realize that the different colors of the rainbow, you can't mix them. They're set in this wavelength by the power that they have, by the wavelength of energy that they possess. And certain ones like red, orange, yellow, they get filtered out of the water as you go down very quickly. Green goes pretty deep, blue goes the deepest. So that's how these things happen. They get filtered out And it's going to determine if you're a plant and you need certain type of pigments of light, which you're going to find out certain plants do need certain pigments, it's going to determine where you're going to live. And it was the Bible scholar Isaac Newton who discovered that that's what a rainbow is. It's a prism, and our light is being separated out. Yes, Isaac Newton, who was a Christian, and he wrote more, if you didn't know this, he wrote more commentaries and papers on the Bible than he did on scientific papers. He was a Bible scholar. But we have a chart here, and I'm showing you on the PowerPoint roughly what I want you to transfer into your on your sheet, because you'll put this into the lab book. This is important because there's some questions on our evaluation that you see here. You see this is by meters, and it depends on the clarity of the water, the conditions of the water that day. There's a lot of things, storms and sediments and plankton blooms, and which is a population explosion. A lot of things vary this. It's not always this precise. Very seldom is it is. This is perfect. But and in some cases, red filters out within just a couple of meters. And you see then orange filters out around 8. Yellow filters out by the time you hit 15 meters. Yellow is gone. By the time you get to 25 meters, no one's snorkeling that far. But if you snorkeled that far, you would see there's no red, there's no orange, there's no yellow. Everything is sort of just green and blue in color. There's a cute Michael moment in your textbook. You can read about me spearing a fish one time in very deep water and how the blood color changed as I went to the surface. But you can see blue penetrates the deepest. And then there's the indigo and then the violet, which are also super deep. We're not snorkeling that far. The point is there are life forms at these different depths that need certain wavelengths of light. So by what they need, by what colors they need, they're going to be found in certain depths. You'll see more of this as we study and we do a lecture on botany while we're down there. It becomes a little bit more easy to understand when you look at these specimens. Let's talk about another abiotic factor, currents. Current is water that is in motion, water that's moving. Rivers have currents. There's down here, you don't see any rivers in the Keys or in the Bahamas. You just don't see them. But there are currents in the water. And the water in motion, these currents are caused by certain things. Number one, surface winds actually have a major play to do with the surface movement of water. Also, the Earth's rotation can do this. Now, down in the Keys, you can try this with your aquarium. Try to cause movement in your water, just going up to the surface of the tank and blowing real hard. Just get up to the surface, like this was the surface of the tank, the surface of the water. Or you can do this if you want. Next time Mom tells you to take a bath, go in the bathtub, lean down there and just blow on top of the water and see, you can move things. So surface winds can cause water movements. Also, the Earth's rotation. Now, I remember when I taught 4th and 5th grade, many years ago, that students, and I was teaching this, I had a unit on physical oceanography, and the students were like, how does the Earth's rotation do that? Now, if I could pause for just a second, I'm going to grab something over here. Sorry. I'm going to grab a globe that I have here, and letting you see this globe, and it spins. Ooh, cool. And the thing is, what I did to help my 5th graders understand this, I had a much bigger globe. I had a huge globe, and I had a student come up and start spinning this in a direction, in a certain direction, the way that the Earth is moving. And they spun this, and I said, now keep it as constant as possible as you're doing this. Don't let it slow down. Don't let it speed up. Keep this constant speed. After they did that for a little bit, and we're practicing, and all the students are gathered around, I took a bottle of white tempera paint, liquid paint, just watercolor stuff, and with a pipette, like an eyedropper, I started to drop it down at the poles. And as they spun this, they noticed very soon as it starts leaving the poles, and as it comes down, let me move it up to this camera, as it would move down, as this spun, it would start to curve in a certain direction. Then it reached the equator, and it didn't, but as it went below the equator, it went the opposite direction. North of the equator, it started to move clockwise. South of the equator, the paint, as it went on down, it didn't make a straight line, it curved and then curved back. the ocean, or I'm sorry, the Earth's rotation actually causes the currents. It's really interesting. Another thing that can determine the currents, land masses. Now, as we are going to be in the Keys, we're going to notice there's a lot of islands here. And in the Bahamas, there's over 700 islands. The tides can be affected this way because we have these land masses, but currents also. As the water is moving with the tides, it's causing currents in between these islands. We don't let people swim in between these islands because the current can be really strong, particularly when the tide is changing. You got a very strong river that can have the water moving maybe up to 10 miles per hour. It can really take you back out to sea. So we're very cautious of this when we're in the Keys. And I noticed this too when I was a kid in the Bahamas, that in between islands, boy, there can be quite a current going through here. And now we know that the islands can cause, and land masses can actually channel the water like in a funnel, and it speeds up as it goes through there. That happens too. And there's mountains under the sea, and currents are just not on the surface. Currents are all the way down to the bottom of the ocean. There can still be strong currents down there. And obviously that's not from the surface winds, it's more from the rotation of the Earth is what's causing that. Even when they went down to the bottoms, like around the Titanic, to the Bismarck battleship that was sunk and other sunken ships, they get down there. Sometimes it's not a good time to take a little submersible down there because the tides are too strong. Or not the tides, the currents, excuse me. The current can be so strong, it can move around. Also, things get stirred up. So you have days like that. Now, what I've done right now is we've got a PowerPoint up here showing the slide dealing with the ocean currents. And if you notice on this slide, above the equator, the currents are actually moving clockwise, where below the equator they go counterclockwise. Now, a person sent me just this past week a really interesting video showing the history, since they've been recording history, of tropical storms, hurricanes, cyclones, etc., and with maps of all the lines on them. What was fascinating to me was at the equator there are none. None of the storms, not one storm, crosses from the northern hemisphere to the south or the south to the north, because the currents, you can see, they go opposite direction as they get close to the equator, so they don't cross over. Isn't that cool? But that's how it is. Now, the current that is going to be affecting us, if you see the United States, it's going up the east coast of the United States. This one affects also the northern Bahamas, and that is the Gulf Stream. So when we go out in our boat, when we charter a boat and take us out to Looe Key, and we're going to be way out, about 8 miles or so out into the ocean, the Atlantic Ocean. When you get out there, you'll be able to see the Gulf Stream, because off just a little bit further out, the water turns a sapphire blue. That is that current area, and that's where you see a lot of fishing charters and stuff going, because they're fishing for sailfish and tuna and dolphin and stuff like that. Not dolphin, the flipper. It's dolphin. Sometimes they call it mahi, though that's the Hawaiian name for it. In the eastern part of the United States, we call it dolphin, and it's a pretty fish, but boy, they're good to eat. But anyway, let's move on. On the next slide I have here too is showing a close-up of the southern tip of Florida. You can see the Florida Keys, and if you can look carefully how the islands at the very end of Florida sort of go, there's a long one almost like connected to the very tip of Florida. Then there's a space moving down to the what would be the south and west, and there's another island. That's where we're staying. That's the Middle Keys, and that's where we're going. Where you're going to be diving is almost all the way down to the end when we go out to Looe Key. But again, this is showing you the currents. You can see the currents going in different directions and stuff because the peninsula of Florida messes them up. But you can see the Gulf Stream just streaming up towards the north, and that is the most famous one. Another part, let's move to another section. Let's talk about waves for a minute. Now, when you go to the Keys, this is a little, maybe a commercial here just to break up the monotony of things. I hope if you're starting to lose interest on this lecture, because physical oceanography is not a lot of people's favorite topic. But anyway, need a break every now and then. So let's talk about waves. Are you waving? In the Florida Key, now we wave, see, people in different cultures wave in different ways. We have some people like in the Midwest, when they wave, hey, hey, like this. Other people, they wave a little like, like that. Other people will wave like so. The Queen of England used to always wave what they call in the Keys and the Bahamas the turtle wave. Isn't that cool? So down in the Keys, I'm not making this up, they actually, people will sometimes wave just like this, and they call it the turtle wave. Isn't that bizarre? Has nothing to do with marine biology. We're just killing time as we go into the next topic, which is waves. Waves are caused mostly by the wind. Again, get in your bathtub tonight, get your face down by the water. It's always important to wash your face anyway, and blow really hard on the surface of the water. You'll make waves. Woo, cool. How neat is that? But how it affects living things. Waves, very important at the shoreline. At the shoreline where we're going to be studying along the shore, waves come in. Sometimes it's just a little ripple coming in, really calm, no big deal. But sometimes you get some big, honking, huge waves come in and smash against the rocks. And you can see there's a Michael moment in there about me getting drenched by a wave in your textbook. But the thing is, waves can hit with a tremendous force of water, and it can smash many organisms. So when you get to the rocky coast areas, when we study there, when you go there, you're going to notice the animals there are a little bit different than you see like in the mangroves. In the mangroves, they cannot handle, many of the creatures can't handle a wave shock that's really strong. Rocky coast, you got really armored things. So it's an abiotic factor, these waves and the way that they hit the shore and stuff. And wave height is from the trough, the very bottom of the wave, to the top of it, the very crest part. That's the wave height. The worst we've ever seen on the Florida Keys trips is like 4 to 6 foot waves, and we generally don't like to go out in that. Most of the time, and this is what you want to pray for right now, is calm seas, no wind, no waves. That's what we want. And water temperature in close to in the low 80s. That's ideal for us. And plenty of sunshine. But anyway, the waves, many times when we're there, are very calm. If you look at the cover of your textbook, in fact, you will notice that there's not many waves. This is about 6-7 miles offshore. Yet you can see there's very little waves here. So that's what we want, is that type of thing. And the frequency is how many waves come in how many times they pass through a point is what we're talking there. And the length of the wave is from one crest to the other. But the primary thing is the height of the wave. And that's, like I say, from the bottom to the top. And it can be a little confusing to some people when they get there, but it's mostly caused by the wind, and wave shock does affect animals at the shoreline. Now, if you need to take a break, this would be a good time because we're shifting gears totally at this point. We're going to be talking about biotic factors. So the biotic factors, these are living things affecting other living things. So it's a living part of the environment, an animal or a plant or a bacterium or something like that, that is affecting other living things. And this is where we start getting into the fun stuff, in my opinion, the fun stuff of marine biology. And the first thing I want to talk about are coral reefs. Everybody wants to come down and see corals. I often get asked, Michael, why do you do this trip down in the Florida Keys? Why don't you go to the Bahamas or Hawaii or whatever? Well, the trip is a little expensive, and I know it is. We do not make a profit on this trip. What it costs us to do it, that's what we charge. Our teachers that come, they don't get paid. I don't get paid. We do this just because we love doing this and we're serving our Lord and God. That's why we do this. And so this is what it costs us to do that. Most of our cost goes to the hotel. That is very expensive. Another high expense is the food cost that we have. But a lot of people wonder, why aren't we going someplace else? It's just too expensive. To go to the Bahamas, trying to fly everybody to the Bahamas, there's places there I would love to take you because the water is clear, the reefs are much healthier, but you got to fly there or take a boat there. So why the Florida Keys? They're the only coral reefs you can drive to in a vehicle in the United States, on the continental United States. The only place. You don't see coral reefs off Texas. You don't see them off Virginia or Maine. You don't see them off California. There's reasons for that. Most of these are going to be like dealing with temperature and stuff. But these are some factors that make why we do it in the Keys. You can drive there, so that's why we do it. And we got to haul all the equipment. Well, coral reefs. Coral reefs are the most diverse area of life on the planet. Now, some primarily elementary school teachers would say, and they say in some of these books, that it's tropical rainforest. Actually, that's not correct. By square meter on a really dense coral reef, you're going to find much more life than you find in a tropical rainforest. It is the most diverse place. And for a coral reef to form, coral is an animal and it needs certain abiotic conditions met. One, it must have very clean water, clear water. So if you're in murky areas, waters that have rivers and stuff coming through and carrying sediment, like around New Orleans and stuff, even though the water is warm, no, it's too murky. You're not going to be able to have coral reefs there. Second, the temperature has to be just precise for many coral polyps, the individual polyps, to live. And it's somewhere between, depending upon species now, but the average is around 20 degrees Celsius to about 31 degrees Celsius. Can't go above, can't go below. That's Celsius. Fahrenheit, that would be 68 degrees Fahrenheit to 88 degrees Fahrenheit as like the top temperature. There are corals that can survive even water over 100 degrees Fahrenheit. You do see these at times. There's certain species in the Bahamas in particular that are like that. But in that water, 88-degree water, that's what I love, Fahrenheit, not Celsius. That would really burn my tushy, so we're not going to do that. Another thing that they really need is they need red algae. Wait a minute, that's a living thing, right? Yes, a living thing affecting another living thing. Red algae is an biotic factor for corals. The other two, the water and the temperature, the clarity of the water temperature, that's abiotic. But red algae is a living thing affecting corals. We'll learn more about that when we get to the botany section down there. Also, there's another abiotic factor corals have to have. Corals need something to grow on. They just don't grow floating in the ocean. They got to be attached. They got to fixate on some type of an object. Now, it can be a sunken ship, it can be a rock, it can be a boulder. There could be anything even old tires have been used to make new reefs, that they've tied them together, put rocks and stuff in them, and dumped them in the ocean, and they form reefs. Coral polyps need something to attach to. So those are some of the necessities for success. Now, there's different type of reefs. I'm going to show you, I'm hoping you're looking at these pictures because these are so cool. This is called a fringing reef. Fringing, just like the fringe of a shirt or a jacket or something, it's attached really close, like, it's the end of the sleeve. These are reefs that are right up close to the shore. They border right on the shore. These are the ones, if you go to an island, you go snorkeling off the island, you're probably on a fringing reef in most cases. And what you see here in this picture that I'm showing you right now on the PowerPoint, you can see the deep blue colors. Well, that's the water itself. But you'll notice some brownish, greenish brownish color. Those are actually coral reefs. And they're growing very close. You can see the beautiful shoreline going up there along the island. Wouldn't you like to be there right now? Anyway, that's a fringing reef. Another type of reef is the barrier reef. Maybe you've heard a couple of these, like the Great Barrier Reef off Australia. There's another barrier reef off Belize. There's another huge barrier reef, which is off Puerto Rico. And the Bahamas has a nice sized barrier reef. Third largest barrier reef in the world. It's called the Tongue of the Ocean, which is off the eastern side of the island of Andros. And barrier reef means that it forms a barrier. There's a water in between. Have the coral reef way out there. Then there's the reef here. There's a water space in between, and then you have the land. Great Barrier Reef can be, in some cases, these reefs can be, scores of miles wide. They're huge. Like the Great Barrier Reef can be over 100 miles wide. These are huge. The largest types of reef are barrier reefs. A third type is, you see this mostly in the Pacific. There's a few in the Caribbean and in the Atlantic, but very few, and that's an atoll. An atoll is like an island where the coral is around the edges, but the island has sort of sunk or eroded or broken down, or God just decided to make a little pit there. And there's a lagoon inside the middle. Atolls became very famous in World War II because in the Pacific, the Japanese used atolls to build on little strips of islands there. They would put airfields and the Americans needed to take these. There were some terrible battles taking place at some of these. One of the most famous was Tarawa Atoll, and they have a lagoon. There are lots of coral all around, but they're beautiful. Now, those are your three major types of reefs. There's some minor ones too. Minor type of reef, these are found in the Florida Keys and in the Bahamas, very common, artificial reefs. They intentionally sink ships. And just recently, been following the news, there's a huge ocean liner called the SS United States that was the fastest ocean liner ever built, and it's been just sitting rusting as a hulk for a couple of decades now. It's been sold, and they're going to take it down and dump it out into the ocean to help form a reef. But sunken ships, actually what you're looking at here is the hull on the center of the picture going to the right is an actual sunken hull of a ship, and coral is growing all around this and on it. I have dove on many sunken ships in the past. There's some famous ones off the Florida Keys that are just covered in coral today. And that's an artificial reef. It was either intentionally or accidentally sank, and coral just grows on it. It will attach to it and start to grow if the conditions are right. Another type of reef you're going to be very familiar with is called a patch reef. Now, notice in this picture, I know it's sort of bizarre unless you get a little clarity on what it is. The turquoise color, of course, is the ocean. The dark colors that you see here, just globs, just look like randomly put all over, those are coral reefs. But you'll notice between the globs, it's like a light color, that's sand. So there's sand patches in between globs of coral. Two very, very well-known patch reefs that we sometimes visit in the Keys is a place called Sombrero Reef, and the other one is called the Coffins Patch. And they are patch reefs. But we're going to take you to a different type of reef this year. We're going to be going to one I haven't been to on a marine biology trip in recent years, but I just love this reef. It's my favorite reef in the Florida Keys, and it's called Looe Key, and it is what's called a spur and groove. Now here you can see the picture of this. Notice there's a lighthouse there. Looe Key, Looe Key, there's a story in your handbook all about Looe Key. It was once an island that got washed over by a hurricane, and the island disappeared, and now it's all covered with coral. You can see grooves going in parallel towards the lighthouse. And here you can see there's a ton of sightseeing boats and snorkel adventures and stuff, and scuba divers that dive here. The reef bottoms out over at the bottom left hand of the picture here. That's about 40 feet or so. It goes all the way to about a foot up to the surface as you move towards the lighthouse. That's where you do not want to snorkel if there's any type of waves, because it can throw you against objects and get you cut up. So we stay in those spur and grooves. So they're long channels with sand in between. Really beautiful reef. Matter of fact, this is always voted the most beautiful reef in the Florida Keys. And a lot of photographs that you take, you see in advertisements for the Florida Keys, the photographs come from Looe Key. How do I know that? I called up Skin Diver magazine one day because they always had beautiful advertisements for corals and diving down in the Florida Keys. They never said where they were at. They just showed beautiful background pictures of the reefs. And I dove in most of the reefs in the Florida Keys, and I was like, man, where are they taking these pictures? So I called Skin Diver magazine, asked for the advertisement department, and I asked them, where are you getting these beautiful photographs of the corals in the Florida Keys? And they said, oh, we take all of those pictures from Looe Key. And that's where we're going to take you this year. It is a beautiful reef. You will see tons of coral, many different species, lots and lots of fish. We've seen turtles there. On one occasion out there, we actually had manatees. We often see dolphins out there. So, and we do see sharks out there also. And so it's going to be one of the highlights of the trip going out there. I love going to this reef. But that's called a spur and groove. And you can read about the history of Looe Key. I won't go into that now. It's in your handbook. You can read all about it. Let's go to another thing here having to do with biotic factors. Ecological roles in the marine environment. Now, you're going to hear this term used frequently, and it's pronounced in two different ways, either a niche or a niche. What it is, it's the role of a species, of an organism, in its community. What's its job in the community? Just like if you live in a subdivision or something, or in a small town, everybody has a job. You live in a certain place. You go through your life every day basically doing the same thing. That's your niche. That's what you have here. Well, all animals and plants have some type of role like that in their environment. And it includes what you're feeding on, the safety where you're living, the habits that you have. You all, each one of us, we all have a niche. And we'll see this and we'll talk about these things of these different organisms that you'll collect, and we'll ask questions. You know, what are they feeding on? What do you think they eats them? What's their habits? What do they do? You're going to ask questions like this and be asked questions like that as we go through this. One key thing having to do with the niche of an organism is its feeding, what we call the feeding level. Now, there's a group of organisms, we'll have a whole lecture on this, dealing with autotrophs. Autotrophs, auto, like we get the word like automatic. Troph is a word coming for feeding. So automatic feeder, if you will. Sometimes you might have heard plants called producers. Plants are also autotrophs. What this means is they make their own food. Through the process of photosynthesis, we will have a whole thing on that later on, but those are producers. They're at the bottom of the food pyramid. You got to have producers as the basis of your feeding levels. They are the most important thing, and there's a lot of them, because just like we grow gardens and have farm things, we all live off of plant material that gets energy from the sun. These are autotrophs or producers. The ocean has these too, and some of these are beautiful to look at, and some get quite large. What feeds on producers are what we call heterotrophs. Now, autotroph makes her own food. Heterotroph goes out and gets food. They find food to eat. These are sometimes called producers. Maybe you've heard of producers, consumers. These heterotrophs are consumers, feeding on the producers. They're consumers. They're consuming. They're eating others. That's what they do. And consumers, there's so many different types. Biologists will group them into different categories. We have what's called a primary consumer. Another word for that is a herbivore. They are eating the first level, primary, first, the first level, which are the plants, the algae, the producers. So we sometimes call them a grazer. A cow is a grazer. And snails, many of them, and many mollusks and stuff, not all, but many are grazers. They eat primarily just plant material. So that's a primary consumer. Then the next level up, what feeds on a primary consumer? A secondary consumer. This is not real hard, you see. A secondary consumer feeds on the primary consumer. Then there's another level that is called the tertiary. Tertiary feeds on the secondary consumer. And they are sort of like the top of the food chain, if you will, or the food pyramid. They rule the top. That would be like sharks in particular are the tertiary. Though there can be a lot of animals that fit into that. But there's always another part in a food pyramid that people often neglect, and that's the decomposers. Because they come along after all the others have died, and they decompose it and break it into what is detritus. Detritus is just organic living stuff that's just breaking down and stuff in your soil. If you go out, take a handful of soil in the area you live, put it in a jar, pour some water, shake it up, let it sit for a few minutes, you're going to see little plant material and small stuff floating on the top, twigs, leaf material. That's detritus. That's food for some primary consumers. They will eat that kind of stuff. I'm showing you now a picture of how a food pyramid is put together. See at the bottom, it's the producer, moving up, primary consumer, moving up further, the secondary consumer, then you get to the tertiary consumer. Now, it's just not putting it in that pile like that. That's made into a pyramid for a reason. You have to notice the largest one by space at the bottom, the largest level is the producer. You have to have an awful lot of producers for primary consumers to be able to live on. There's less primary consumers than there are producers. I'll repeat that. There's less primary consumers than there are producers. Likewise, there are less secondary consumers than there are primary consumers. And then you get the tertiary, there's only a few of them in some cases, much smaller in biomass or how many there are compared to the other levels. You see, if you turn this the other way around, if there was mostly tertiary consumers, well, if we turn the whole triangle just upside down, kept the labels, but just turn this upside down, that would mean the producers being at the top, there are hardly any producers. And all the consumers, there wouldn't be enough consumers to keep everybody alive. Everything is balanced in this way by God's intent. It's not by accident or by evolution. This was designed. You need so many producers to keep this many primary consumers alive. You need this many primary consumers to keep this many secondary consumers alive. You need this many secondary consumers to keep the tertiary. A great example of this, just let me explain for a second, is off the coast of California. California, 100 years ago, had seals all along the coast. Great white sharks used to feed on those. Now, the great white shark would be like a tertiary consumer. The seals were secondary consumers because they were eating fish and stuff, which would be the primary consumer, and the fish would be eating the producers and stuff. What ended up happening in the early 1900s, they started hunting and killing all the seals. As they wiped out the seal population, well, what happens if you take out the secondary consumer, you remove it, the primary consumers have a population boom, but the tertiaries are starving to death because there's not many around, that there are many secondary consumers they can feed upon. So what ended up happening, in this case in California, we started seeing more and more a depletion, shall I say, less and less of great white sharks. Great white sharks were eating the seals. The seals were being killed by people. Thus, we took away the food supply of the tertiary great white shark. Great whites disappeared. But then we put certain rules and laws and stuff protecting the seals. Seal population expands dramatically over a span of like a couple of decades. And what do we now see? A lot of great whites off the coast. Why? We brought back the secondary consumer. That's their food. It can support a large amount of great whites, and that's what we see. You see, it's all related, how this is all put together. Another type of biotic factor are biological relationships. Biological relationships, we have a term that is often misunderstood and misused by people, common people. It's called symbiosis. Now, symbiosis is a very general term. There's a lot of different meanings to it, a lot of different types of symbiosis. A symbiosis is simply defined as a relationship between two living organisms. You, as a teenager, are living in a symbiotic relationship with your parents. And, just like if you get a tick on you, it's living off of you. That's a symbiotic relationship. There's a lot of symbiosis that you're going to see in the Florida Keys, and we make note of this as we dive on these reefs and we go to these different excursions. It requires a host and what we call the symbiont. Now, there's a lot of different types of symbiosis. Lots of different ones, but there's three primary ones that we're going to cover primarily in this course. One is called commensalism. Commensalism is when, I've got little smiley faces here to let you see, the symbiont is happy. He's getting something out of this, where the host is getting nothing out of this really. The host is unaffected. The one that has got the symbiont living on him or living with him, he's not affected. He could care less if this other organism is living with him because he's not getting any benefit. But the symbiont is getting benefited. So the symbiont is happy. The host, you can see with the face there, I could care less. Great example of this in the ocean that we sometimes see are these fish here called remora that are attached to sharks. They don't hurt the shark. They don't help the shark. They fasten on with their dorsal fin, which is like a suction cup, and they ride on attached to a shark. Sharks are sloppy eaters. Maybe you know somebody like that. Sloppy eaters. They take hold of something and they shake, and a lot of times and little pieces fall off. These guys then clean up the mess. And they just travel around with the shark. Shark tolerates them. They could care less. It's a commensal. The remoras benefit. They get free ride. They don't have to work hard and swim. They get a free ride, and meals are provided for them. Hey, it's a great relationship. Another type of symbiotic relationship is called mutualism. A mutualism is where both the host and the symbiont are both happy because they're both benefiting. They're both getting something great out of this. And we see these, particularly when we go to the coral reef. I'm going to tell you right now, and I'll try to remind you when we go out onto the big boat, to look for this. A classic example is what you're seeing here with this picture. This is a green moray eel, but notice there's a shrimp, a barber pole shrimp sitting in its mouth. Now, shrimp are usually just, food items, not just for fish, but also for us. You go to Red Lobster, hey, they have shrimp fest and stuff. Well, moray eels, like this one, normally eats shrimp. But this little shrimp here, this barber pole, what he's doing is he's cleaning the parasites off the moray eel. The moray eel will hardly ever eat this cleaner. I mean, he can. I've known it to happen rarely, but the moray eel is getting a benefit out of it. He's getting the parasites off his body because he doesn't have any hands or whatever to take them off. This little shrimp comes along, eats the parasite, and the moray eel lets him live. So the parasite, the shrimp is doing the moray eel a benefit. The moray eel is also getting the benefit of getting rid of parasites and food scraps and stuff. These are great. And you'll see on the reefs a lot of fish, cleaner wrasses and many others will come. They'll set up a station by a coral reef. A big grouper will come over, just stop there, and these little fish just come all around its body, eating all the little parts off that are not necessary or harmful. Then the grouper swims on without hurting them. Mutualistic relationship. There's a lot of mutualistic relationships. Then there's another one called parasitic symbiosis. Parasitic symbiosis, that's when the symbiont is happy, he's getting something greatly benefiting him, where the host is harmed. I know sushi is really popular right now. I don't touch sushi. I won't look at it because of, like in the picture that you see here, this is a fish that's been cut open. You see this worm crawling out. And fish often have worms in them. So eating sushi, there's many types of parasitic worms that were hardly ever found in the United States until starting around the 1980s when sushi became popular. Now we see more and more people getting parasitic worms. As a matter of fact, I won't say where, but I have been in grocery stores and have looked at fresh fish, fillets of fresh fish in the fish market there, picked it up, and I always look carefully at stuff like this, and I have seen worms crawling in it. And it's vacuum sealed in that, but there's worms in it. You can see the worms. These worms are alive. You eat that, you get it inside of you. Now you become the host, and this worm symbiont is living off of you. It's not doing you any good. So we do see parasites, and we don't see them too often. We found leeches on some sharks at times, but the parasitic relationship, the host is hurt, the symbiont is benefited. So now my question is for you, what type of relationship do you have with your parents? Is it commensal? Like your parents could care less if you're there? Is it mutual? You benefit your parents benefit you, which is, I think, the best way of doing it. Or are you a parasite that you're living off your parents? You're taking their food, you're taking up space in their home, and you're giving nothing back. Which one are you? Just talking biology here. That's what we got. The last thing I want to get into is how energy flows in the environment. And it flows through an ecosystem, the environment. And this goes back here. I'm showing you this pyramid again, sort of circling back for a second, spiraling back, looking at the size of the amount of how much it takes at the different levels. We see the primary consumer at the bottom, and then you see the secondary consumer. But notice the pounds. Now, this is just an estimate to show you the idea of what's going on. As you move from one feeding level, trophic level, to the next, the feeding level, the amount of energy that is there decreases about 10%. So in other words, about 1,000 pounds of food are needed to keep about 1,100 pounds of primary consumers alive. It takes about 100 pounds of primary consumers to keep the secondary consumers alive. And then it takes about 10 pounds of those to keep the tertiary, the top ones, them alive, notice that it moves in 10%. Now it's a generalization, it's a huge generalization, but it is roughly how it goes in the environment. That you lose for each trophic level, one feeding off the other, you lose about 10% of the energy as you move up. You'll come across this towards the latter part of our trip as we do this. And these things are all related because there's food chain. So food chain is to help you understand this, because you're going to have to develop, even on this exercise here, there's a spot on your sheet for you to take this and make a food chain. You're going to have to do that on your own. You will also make a food chain for the habitat that you're going to be studying down there. But like in this food chain here, let me just show you something very important that a lot of people make mistakes on. You can see in this case here we have phytoplankton. That's plant material just floating in the ocean. That is the primary consumer. I'm sorry, that is the autotroph, the producer. Now the primary consumer is the zooplankton. Zooplankton are animals that eat the phytoplankton. So about 10% of energy is lost here. Notice the direction of the arrows. This is what I'm trying to get across. Notice the way, when you make a food chain, the direction the arrow goes. It's going the way the energy is moving. So the zooplankton is eaten by small fish. The small fish are eaten by like a mackerel. Mackerel are eaten by mahi. Actually, it's dolphin. And then the dolphin are eaten by the large shark. But you notice the energy is moving in that direction. Don't make the mistake, as many students do, that they put the arrows backwards. They have in reverse, where the shark is giving its energy to the thing it's eating. No, it doesn't work like that. So make sure you get it right. And you're just moving, showing in a food chain the different organisms and showing how they eat. You get to make some of these up as we go along. Likewise, if you have more than one food chain, because the ocean is full of different creatures, you get like what's called a food web. Again, you showed the way with the arrows where the energy is going. So the mahi that you see in this picture, or on the left-hand bottom, just like we saw in the last one, the energy from that is going to the shark as the shark eats it. The fisherman up in the top right eats the mackerel, eats the mahi, eats small fish. You can see the energy is moving that way. Small fish are also eaten by the killer whale, the orcas. So you see we have, and this is the whole thing with the food web. A food web is just a bunch of, really simply, it's a bunch of food chains all overlapping each other. And you have arrows going all over the place. I have an illustration on the handout that I gave you with this. You will be making one of those of your habitat towards the end of our trip. After you studied all these different organisms, you will form one also. Well, we made it. This is the key things that I wanted to get across on this video for you. There are things we have skipped, as you can see from the numerical pages that we have. There's pages missing. Those are labs. Most of these are lab experiences that you will do down there with your group, or we will do all together. So that's what you're missing, and you can't do that till we get there. But this saves us, if you've gone through and managed to live through this lecture, and I promise you, the lectures following this, I will be much more animated, I will be much more fun. This is just the worst way we can do it. So we'll have a lot more fun as we go through these lectures later on and make them entertaining for you. And this helps us, though, to give you that first night off. If you follow through, fill in these answers. Also, just using your gray matter, you can figure out almost all these answers are found right here in the textbook as well. So, hope to see you down there in the Keys. Until then, I want you to do this. I want you to pray for calm seas. I want you to pray for no wind. I want you to pray for warm temperatures, particularly the water temperature being in the 80s. And pray that no one gets sick before or during the trip, and that all your flights will be on time. So if you have any questions, you can contact me or my wife Denise and before the trip. And if not, we will see you down in the Keys at the airport. We'll be there to pick you up at the Miami airport. Our other teachers, Kara, Joey, will be there, and Rochelle, they will all be there to help round you guys up on the map that's outlined in the handbook. And then I will be coming, I will already be down there, I will be coming by with some vans, and we'll pick you up with a trailer, and we'll take you down to our hotel. From Miami, it's about a 3-hour drive to our hotel. So we're going to drive out into a little island on the ocean. Interesting thing about the Keys, they're all connected by just one highway all the way down. In some cases, it's only 2 lanes, so there can be a lot of traffic jams at times. Or if they're doing construction, it's a mess. But anyway, hope to see you in the Keys. Hope you're safe. Hope you're healthy. Take care, and may God bless.